it's going to ask you to divide 6y minus 12 over 2. So, how would you do this? It just says to divide. So, how would you divide? 1, 2, 3, 4, 3 people. Rachel, what would you do if they ask you to divide? Oh, did you have a question?
Is it 6y or 16?
Oh, 16y. I'm sorry, I said 6y, didn't I? 16y minus 12 over 2. Thank you. Rachel, what would I do to divide? What do you think?
I think you could divide both of them by 2 first.
Right. So, knowing what we just talked about, could we separate this into subtraction of two fractions? What would that be?
16y over 2
Uh-huh.
is 12 over 2.
Exactly. So, couldn't we just, we just talked about this fact, didn't we? Right? A plus B over C is A over C plus B over C, right? Same thing. Am I done? No. What could I do here? Does 2 go into 16y? So we could simplify that, can we not? What do we get when we do this, Eric? What would you write?
You get 8y minus 6.
8y minus 6. How many people agree? Good, you are correct. And as you can see, we just, we know how to divide this. Yeah, question?
Wait, could you just distribute out two numerator and then...
You read my mind. I was asking to ask, so then how is all this example that we just did before, previously, example 1 through 3, you know how we factored and everything? Why do they give us all of a sudden, couldn't we just do it this way? How is that relevant, or how is that even useful to do a problem like this? By the way, let me ask you this. Would you have done this if my denominator was like 3 instead of 2? Why not, Viviana? Why would you not? Yeah, 3 doesn't go into 16 or 12. Does that make sense? Because then what would you do then? If there was 3, you just leave it, right? But since the 2 goes into 16 and 12, you could separate them into, right? Difference of two fractions and simplify. So knowing this and knowing what we just did, factoring, Alvin said it correctly. Alvin notices, wait a minute, look at the numerator. Look at the terms, each of those terms. What's a GCF of the numerator, guys? Isn't the GCF of the numerator 2? And doesn't 2 go into the denominator? Right? So I wrote down method 1. Guess what method 2 is going to be? We're going to first factor the denominator or numerator? Numerator. So isn't this cool? So first step 1, you find the GCF, which is 4, right? Can I now factor out the 4 out there? And you say, wait, isn't 2 going to 2? Well, my GCF is 4. But that's okay, because does 2 go into 4? Yeah, that's good. Now, who could then tell me how to rewrite this as a product of two fractions? Think about what we just did up here. Remember, like the first fact, let me, hold on a second. So look at the second fact we talked about. You see, isn't this what we have? What's A, B over C? That's A over C times B over 1. So look, I have 4 times 4y minus 3 over 2. How can I rewrite this after I factor out that GCF of 4? Anybody? Clear?
You can do 4 times 4y and 4 times 3, and then get 16y minus 3 over 2.
Yeah, then we're going back to the original. Yeah, but knowing this, Claire, is there where, if so, this is my A. My 4 is A, my B is this whole binomial over C. So is there 4 over 2 times
4y minus 3 over 2.
over 2 or over 1? Over 1. Does that make sense? Why would I want to separate it this way? Why not just leave it this way? Why? Yes?
You could simplify to
Yeah, I can simplify 4 over 2. What's 4 over 2, class? 2. You see how it's nice? Then if it's 2, isn't this simply then 2 times 4y minus 3? And since we're just dividing, we should simplify at the end, right? How do you simplify this? You just distribute the 2 to 4y minus 3, which is 8y minus 6. Does that make sense? Do you see why this is important? Guess what's a big mistake that people make there? Instead of writing 4y minus 3 over 1, they write 4y minus 3 over 2. Would that be correct? No, because if that was 2, then your denominator would not be 2, would it? It would be. But you see how I knew that I need to do it. I know I want to do it this way because 2 goes into 4. You see how that denominator goes into my GCF? That's why I did it that way. Does that make sense? Do we get the same answer? Look, yeah, we get the same answer. Which way is easier? Method 1 or method 2? Method 1 is easier, yeah, I agree. Sometimes method 1 will be easier, sometimes method 2 will be easier. And we're gonna think about when we want to do which method. Do you think you need to know both? Yes, you do. But we're gonna talk about when to use method 1 and when to use method 2. And as we do a couple of these, it will make sense to you, okay, when to do it and when not to do it. Anyway, let's move on then. Let's try example 2. No, not 2. Example 5, but let me try to hide that first. Hold on. So try example 5, but because I want you to know both ways and I want you to know when to use method 1 and when to use method 2, can you try method 1 and method 2 both ways on this one? At the end, should you get the same answer?
Yes.
Yeah, okay, everybody try. Go ahead. Okay, let's start with method 1 first. First method. Who could help me how to do first method to divide or simplify this thing? 2 people? 3? That's it? Come on. There should be 4? 5? Eddie, can you help me out?
For one, I put 28pq over 7p.
Uh-huh.
And for the next one, I put negative 35p over 7p.
That's what I did too. That's exactly right. Okay. Now, can we simplify each of these fractions? I think so. Who could help me how to do that? One person? 2? Come on, guys. I need some more. Claire, tell me.
Divide by 7
Right.
and cancel out the p.
Good. Which is going to be
4q minus 5.
4q minus 5. How many people got 4q minus 5? Any question? Is this easy? So I like kind of method 1 for this one. Right? So, okay. Now, how many people tried method 2? Everyone should have, right? Okay. Melissa, can you tell me what's step 1 for method 2? We have to then factor the? So what's the GCF of the numerator? 7p. Would you all agree? Okay. You're right. So I know that GCF is 7p. Okay, so what? Now I have that right there. Uh-huh. That's right. Over? Yes. Do you think that parentheses there is important? Yeah, otherwise it's not multiplying, right? Good. And, okay, the next step is, what's that? Really? Who could tell? Oh, hold on. Who could tell me what to do next? One person? I got 7p times 4q minus 5 over 7p. Well, look, you got 7p on the top, you got 7p on the bottom. What do you think I'm going to write next? Yes, Kaylee?
7p over 7p
Uh-huh.
times 4q minus 5 over
Yep.
7p.
Over 7p?
Oh, sorry, 1.
Over 1. Be careful, this is over 1. So, you see 7p is cancelled out, you get 4q minus 5. How many people got that one right? Good. Now, can you then, which one's easier for this one? First, well, is second one that much harder at all? No. Why is, I kind of like second one. Why? Because they canceled out, right? They canceled out. So, how many people think they know when to use method 1 and when to use method 2? Lucia? When the GCF and then the denominator is same? Kind of. Actually, there are other cases where you want to. You're right, that's one of the cases, but also anybody want to add something to that? It turns out, no? Yeah, we'll do a couple more, okay? But you need to know how to do it both ways, okay? Because later it's going to be helpful. But anyway, so we'll do a couple more examples and see if that helps us, okay? Let's try example 6. Again, I want you to do it both ways, method 1 and method 2. Okay, I got 4x fifth minus 24x cubed y plus 10x squared y squared over negative 2x squared. Just looking at this, do you think method 1 will be easier or method 2 will be easier on this one? Method 1, 2? Well, go ahead and try it. Everybody try it. See what you get. Okay, let's do method 1. So did y'all... Oh, whoops. That's hold on a second. Can I do method 2 first?
Yeah.
Okay, and then I'll show you method 1. So method 2, I factor out my GCF, which was 2x squared. So those of you that try method 2, and I kind of like this, look, because doesn't the denominator go into that GCF? How many times does it go in? By the way, let me write this. So don't I get 2x squared over negative 2x squared times that whole trinomial over 1? Over 1, right? This is important, over 1. Yes? And how many, what do I get? What's 2x squared over negative 2x squared, class? Negative 1, because I get negative 1, positive 1 over negative 1. So that's negative 1, right? Then, guess what? I should distribute the negative 1 throughout the whole trinomial. How many people got negative 2x cubed plus 12xy minus 5y squared? Raise your hand. If you didn't, please ask questions. Any question? Does that make sense? So, yes.
Is it okay if we wrote it in order of decreasing exponents? So negative 2x cubed minus 5y squared plus 12xy.
Actually, if you're going to write them in decreasing order, you have x right here. So it'd be, wouldn't you have x in the middle? Yeah, this is the right order. Good. Now, and those of you that did method 1, did you separate it like this? And then when you do, you get 4x fifth over negative 2x squared plus negative. So I wrote everything as addition, you see? So I don't want to make a mistake. Negative 12x 24 x cubed y over negative 2x squared plus 10x squared y squared over negative 2x squared. Yes? And do you get the same answer and you simplify? Which method do you like better? Method 1 or method 2? Method 1, 2? To be honest, it doesn't really matter, but I kind of like method 2 better because you don't have to separate the whole thing like this. I don't know. As long as you get the right answer, that's all, okay? But you should know how to do both ways. Okay, then, are we okay with these? Why don't you try example, then the next example, okay? Hold on. Which one's easier? So with this example 7, you will really see when it's useful to use method 1 and when it's easier to use method 2, okay? So everybody try example 7. And again, try both ways. I know that some of you like one method better than the other, but you need to know how to do both ways, okay? So go ahead. It says 6r cubed t minus 18r squared t squared plus 3r all over rt. Okay? Everybody try. Both ways, okay? By the way, how many people tried method 1? Raise your hand. On this one. How many people tried method 2? Okay. Now, is it okay to choose, does both method work? Yeah, they both work. Which one do you think is better? Raise your hand. How many people think for this one? Because I think this one kind of shows you when, you know, like, both of these methods are fine. It's just, you know, sometimes you want to use one than the other. Which one do you think is easier to use? Yes, Audrey?
2.
Method 2, where you factor out the GCF. Okay, how many people think that 2 is better? How many people think 1 is better? Oh, a lot of you. What did you say 2, Audrey? For this one.
I don't know.
Oh, is that what you did it with 2 and you got, okay, that's fine. Yeah, but actually I think for this one, method 1 may be a little bit easier. And I'm gonna show you both ways. And we're gonna think about why, okay? So let's do method 1 first. So what would I do, Michael? Well, how would I then, if I'm just doing the method 1, how do I separate this into 3 fractions?
You get 6r 3t over rt
Uh-huh.
minus 18r 2t over rt
Mm-hmm.
plus 3r over.
Yeah, uh-huh. And so that's what I got. And I actually changed everything to addition. So is that okay? Instead of writing, okay, that's fine. Then let's look at each of these fractions and we just simplify, right? William, can you show me how to do that? What's the first fraction going to be when I simplify? 6r cubed t over rt.
6r squared t plus.
Oh wait, 6r squared t? Don't the t's cancel out too? So you get 6
Square
6r squared, right? Good. Plus what?
plus that is 18r t plus 3 over t.
3 over t. Very good. Right? Is that okay? Then, of course, I could rewrite this as subtraction, right? Any question? How many forgot this as your answer? Raise your hand. Okay, so with method 1, this is what you get. With method 2, do you think you should get the